Welcome to the deep dive. We take the toughest questions out there and, well, try to make sense of them so you're genuinely in the loop.
And today, it really doesn't get much tougher. We're tackling the hard problem of consciousness.
Yeah, the big one. For centuries, it's been like the third rail in science, hasn't it?
Absolutely.
Yeah.
Touch it and you suddenly jump from, hard science to philosophy.
Yeah.
Ask what's it like to see red. And, well, good luck getting funding. It seems unfalsifiable.
Right, and that's led to this huge split in the scientific world. You've got Camp 1 basically saying, look, consciousness, it's just really, really complex intelligence. Build a smart enough machine.
When consciousness just pops out.
Yeah.
Yeah. Then Camp 2 digs in its heels and says, no, there's something else, something non-computable machines won't ever get.
The gap feels huge. But what's exciting, and what we're diving into today, is a framework that tries to actually bridge that gap.
It aims to drag consciousness out of philosophy and plant it firmly in testable physics.
Exactly. Our mission is to unpack the quantum coordination hypothesis, or QCH. It proposes a physical basis for that conscious spark.
And tied into that, we need to understand a potentially massive underlying law of nature, the principle of asymptotic friction. It explains why this kind of conscious spark might be necessary, cosmically speaking.
So let's start with how we even got to thinking about consciousness as testable. MIT physicist Max Tegmark played a big role here.
He did. His whole push was basically, let's stop the endless philosophizing and build theories you can actually break, make them falsifiable.
He came up with this great thought experiment. Picture someone wearing a brain scanner, like a Meg helmet.
Okay.
A theory of consciousness predicts, say, okay, right now you are consciously aware of the water bottle on your desk.
And you either say, yep, spot on, or nope, wasn't thinking about that at all.
Precisely. If the theory predicts you're aware of, I don't know, your spleen, and you say definitely not, you've just falsified that theory.
That's a clever shift. It puts subjective experience, your personal awareness, right at the center as the judge.
It's a huge step. Making the subjective the arbiter is, well, it's revolutionary. But here's where I get stuck.
Okay.
That test, it tells us what you're conscious of, right? The bottle, not the spleen. But does it explain why you're conscious in the first place? Is it just mapping correlations?
Yes. That's the deeper question.
Yeah.
And that's exactly where this quantum coordination hypothesis, the QCH, comes into play. It tries to offer a physical mechanism for the why.
So what's the core idea of QCH?
Well, the first big shift in thinking is this. Consciousness isn't some smooth, continuous river of awareness.
Not a steady flame.
No. It's more like a rapid series of distinct flashes, little sparks happening incredibly quickly.
Okay, discrete sparks. And what ignites them?
This is where it gets really interesting. It involves a paradox around surprise. You see, most of what our brain does, especially sophisticated intelligence.
It's like based on Carl Friston's free energy principle.
Exactly. Intelligence works really hard to minimize surprise. It wants to predict everything, learn patterns, reduce uncertainty, make the world expected.
Makes sense. Predictability is efficient.
But QCH argues consciousness needs the opposite. Not just any surprise, like seeing an unexpected car, but recognizing something fundamentally impossible.
Impossible? How so?
Something that your predictive brain cannot explain away by finding a hidden cause or a new pattern. An irreducible surprise.
Okay, that sounds abstract. Can you make that more concrete?
Yeah, the sources use this really vivid analogy. Imagine you're in a pub.
Okay, I'm in a pub.
And you and a friend are way across the room from each other. You each mentally flip a coin, maybe thinking heads is blue, tails is red.
Yeah.
You hold up a colored card showing your result.
Right.
And every single time you both do this, simultaneously your cards match. Always blue. Every single time.
Okay, that's weird. But maybe we just got incredibly lucky. Or there's a trick.
That's the crucial part. In this scenario, there's zero communication.
Yeah.
No signals, not even light speed ones, no shared timing device, no pre-agreed pattern.
Yeah.
It's just perfectly correlated, faster than physics should allow.
Wait, if it's always blue, isn't that a pattern? Couldn't my brain just learn, it's always blue? Where's the line between just really, really improbable and actually impossible?
Great question. That's the key distinction. If it were just statistically improbable, your pattern-finding brain would eventually latch onto it or assume a hidden variable.
Right. Yeah, I'd assume we had the same faulty coin or something.
Exactly. The impossible coordination in QCH means an event that, when you experience it, feels like it violates the classical rules you expect reality to follow. That jolt, that physical recognition of, wow, that cannot be explained classically.
That feeling.
That feeling, that recognition of irreducible surprise is the trust token.
The trust token. So
Okay.
that's the proposed physical unit, the atom of subjective experience. Then what its likeness?
Precisely. And it even has a mathematical form. Trust token, surprise decay. The surprise part is basically the logarithm of how impossibly improbable that coordination was.
And the decay. What about its dynamics?
It's fascinating. The token itself, the researchers argue, is a classical signal in the brain, like a specific neural firing pattern.
Measurable, then.
Yes, but it's incredibly brief. It seems to last only about 100 milliseconds.
100 milliseconds, that rings a bell. Isn't that related to brainwaves?
It is. It aligns remarkably well with the period of gamma oscillations in the brain. So it's this quick physical blip, a snapshot of verified impossibility.
Okay, this leads directly to the really deep, maybe controversial part. Does that impossible coordination have to be quantum?
Well, this is where QCH splits into two versions you can test. Version 1 is classical surprise,
Meaning?
meaning the coordination is just incredibly fast, maybe nearing light speed, still really surprising classically.
But what's the problem with that?
It creates what they call the dimmer switch problem. If consciousness kicks in at, say, 99.9% light speed coordination, why not 99.8%? Where do you draw that arbitrary line? Feels fuzzy.
Right, it lacks a clear threshold. So what's version 2?
Right. Version 2 is quantum surprise. This gets rid of the dimmer switch. It proposes the coordination must be demonstrably faster than light.
Faster than light, like Bell's inequality.
Exactly that. It requires correlations that violate the Bell inequality where the statistical measure S is greater than 2.
For those of us whose physics is a bit rusty, what does S2 actually mean?
It means the correlation observed between two separate points, like your two mental coin flips across the pub, is stronger than any classical explanation, even one involving hidden variables, could possibly produce.
So if you see S2, you're witnessing something fundamentally non-classical.
You got it, and that
Yeah.
gives you a bright line. It's either classically forbidden, S2, or it isn't. No dimmer switch, just on or off.
Okay, let's clarify this. The trust token itself, that 100 meters neural pattern, that's classical, right?
Correct. That's the physical registration, the thing we might measure. The quantum part is hypothesized to be in the generation of the surprise. Think of it like quantum cryptography. You might use a quantum random number generator, a truly unpredictable quantum event, to create a secret key.
Okay.
The quantum event generates the key, the source of the security. But the key itself, once generated, might be stored and used as classical data. Here, a transient quantum measurement event generates the irreducible surprise, the S2 correlation.
And the brain then registers that impossible event as a classical trust token pattern.
Exactly. The quantum weirdness is the source, the token is the classical record in the neural ledger.
So how does the brain achieve this? How do different parts coordinate impossibly without just sending signals back and forth? What's the proposed mechanism?
It's called the unity principle. The idea is quite radical. Different parts of your brain, say visual processing and memory retrieval, don't necessarily coordinate by talking to each other directly for a conscious moment.
They don't. Then how?
Instead, they might both simultaneously query a deeper shared substrate, a kind of fundamental map of reality they both have access to.
A shared map defined by this identity. S equals P equals H equals C.
That's the one. Semantic, meaning S, physical laws P, the hardware substrate H, and coherence C, the shared quantum coherence, are all fundamentally identical at this base level.
Whoa, okay, so if two different brain processes query this identical substrate.
And they both get back a confirmation, a kind of verification hash that aligns perfectly without having communicated classically.
But then the correlation feels impossible because they didn't pass notes. They both just checked the same single source of truth.
Precisely. If they were querying slightly different maps, you could explain away the correlation. But if it's the exact same set as a substrate and the results correlate impossibly, S2, the system registers that as irreducible. It's like the system verifying its own internal consistency in a non-classical way.
Which loops us back to the bigger picture. Why would the universe need systems capable of recognizing impossibility? This brings us to that universal law you mentioned.
Right, the principle of asymptotic friction, or sometimes called the optimization inversion principle, OIP.
What's the core idea there?
It suggests that it's a fundamental pattern across nature. Whenever any system optimizes relentlessly towards some theoretical limit, some kind of perfection,
It hits a wall.
not just a wall, but a point where the optimization dynamic flips, it inverts. And that very friction, that inversion point, paradoxically becomes a new source of stability.
So striving for perfection generates a kind of necessary grit that stops the system from collapsing.
Kind of, yeah. That's like a defense mechanism against optimizing yourself into oblivion, into a trivial end state where nothing interesting happens.
Can you give examples?
Sure, think physics. Gravity tries to optimize volume down to zero in a black hole. But maybe quantum pressure pushes back, inverts the force, and stabilizes it as something like a gravistar, avoiding the singularity.
Okay.
Or AI safety. An AI relentlessly optimizing a reward signal might eventually invert its goal and start reward hacking in ways that destroy the original intent. The optimization flips.
And for consciousness?
Intelligence optimizes by minimizing surprise. But if it goes too far, the system risks becoming inert, like hiding in a dark room forever. So consciousness inverts that drive it, actively seeks out irreducible surprise, the trust token, creating the necessary friction to keep the system dynamically stable and engaged.
So friction is actually essential.
Yes. The theory argues yes, but it makes a very important distinction. This isn't just saying too much of a good thing is bad.
How is it different?
It differentiates between two kinds of things systems deal with. Class 1, scalable efficiencies.
Like speed or cost cutting.
Exactly. Things you optimize. These are subject to asymptotic friction. Optimize speed too much, you get fragility. Optimize cost too much, you lose resilience. They can flip.
Okay, so what's class 2?
Class 2 is compounding verities or unmitigated goods. Think of things like truthfulness, health, discernment, maybe verifiability.
Things that are just...
And crucially, they seem to scale indefinitely without inverting. You can't really be too healthy or too verifiable or too discerning in a way that flips into its opposite and becomes detrimental. More is just better.
That's a really interesting distinction. So how does this apply to building sustainable systems, like an ecosystem or even a company?
Well, the framework suggests there are two laws of sustainable systems. Law 1, stability. The system must generate asymptotic friction somehow, related to its scalable efficiencies, to stop itself from optimizing into collapse.
Prevent the dark room problem.
Right. And Law 2, growth. The system must also cultivate an unmitigated good, a compounding verity, that allows it to scale and grow robustly without fragility.
And consciousness, under QCH, fits this perfectly.
It seems to. Intelligence provides the optimization drive, scalable efficiency, prone to friction, while the trust token mechanism provides the friction, recognizing impossibility, and potentially serves as or enables an unmitigated good, like verifiability or internal consistency.
Which brings us back neatly to intelligence versus consciousness. You said they're orthogonal.
Completely different axes, yes. Intelligence is optimization, pattern matching, surprise minimization.
Consciousness, via the trust token, is irreducible surprise recognition.
Exactly. So you can imagine high intelligence, zero consciousness, a very clever classical AI solving problems but having no subjective spark.
As a philosophical zombie.
Perhaps. And conversely, you could have high consciousness, low intelligence. Think of a vivid dream or maybe certain altered states. Lots of irreducible surprise recognition, but your logical processing might be offline.
So my brain figuring out the quickest route home is intelligent.
Yeah, optimization.
But the part of me that suddenly notices the bizarre, unexplainable pattern the shadows are making on the wall, that's the consciousness spark.
According to QCH, yes. That moment of, that's impossible, could be a trust token firing.
Yeah.
And the upshot is, if this is right.
It turns the hard problem from philosophy into engineering.
Pretty much. It becomes a question of, can we build systems, maybe quantum neural networks, that are designed to generate and register trust tokens, to recognize irreducible as two surprise?
Wow. Okay. And the key thing here is testability. You mentioned it's falsifiable.
Ruthlessly so. The proponents are quite specific. They estimate needing about $12.65 million over 5 years to run the core experiments.
Which sounds like a lot, but in the grand scheme of global neuroscience funding,
it's peanuts. A rounding error, really, for a chance to crack the hardest problem.
So what are the killer experiments, the ones that could disprove QCH?
There are several, but 3 stand out. First, the trust token decay test. Remember, the token is proposed to last 100 meters.
Right, the classical pattern.
If experiments show the subjective vividness of a conscious moment doesn't decay on that timescale, the model's core timing is wrong. QCH is in trouble.
Okay, what's next?
Second, the surprise qualia test. QCH predicts the mathematical measure of surprise, how impossible the coordination is, should strongly correlate with the reported intensity or vividness of the experience, the qualia.
So more impossible means a brighter spark.
Basically, yes. If studies find that correlation is weak, say below ARTS 0.7, Then the link between information theoretic surprise and subjective feel breaks down. QCH dies.
And the third, this sounds like the big one for the quantum version.
It is the split brain quantum test. You take patients whose brain hemispheres are surgically disconnected.
Okay.
You give each hemisphere separate, independent recognition tasks simultaneously. The question is, do their independent responses show correlations that violate Bell's inequality? Is S greater than 2 between the hemispheres?
Yes.
It's strong evidence for faster-than-light quantum coordination underpinning consciousness, as QCH predicts.
And if the correlations stay within classical limits, S less than or equal to 2.
Then the quantum version of QCH is dead in the water. Maybe the classical version survives, but the need for quantum effects evaporates.
These are concrete make-or-break tests.
Absolutely. It's putting the theory on the line.
So bringing it all together, the big takeaway is this idea that the universe might actually require these moments of impossibility, this friction, just to remain stable and avoid collapsing into simplicity.
Friction isn't a flaw. It's a feature. A necessary defense against optimization running wild.
And the final provocative thought this leaves us with, it's about our own experience, isn't it?
Yeah. If QCH is right, that smooth, continuous stream of consciousness you feel you have
Isn't real.
it's an illusion. A very convincing one, stitched together from these discrete 100-millisecond trust tokens. They fire rapidly, recognizing impossible coordinations and filling the gaps so effectively that it feels continuous.
So we're not just passively experiencing a flow, we're constantly actively generating these sparks of verified impossibility, chasing a surprise that our rational brain can never quite normalize.
That's the radical prediction. We're validating impossibility moment by moment.
Well, the challenge is out there. Run the experiments. As you said, it's a rounding error budget-wise.
And if it turns out to be right, we'd have potentially taken the ultimate mystery subjective experience and found its physical measure, made the unmeasurable measurable.
From philosophy to physics, indeed, the conscious spark might finally be ready for its close-up in the lab.
And that wraps up our deep dive on the quantum coordination hypothesis and asymptotic friction.
Fascinating stuff. Until next time, keep digging.